What's up, everybody? This week, there's those. This week we were talking about the urinary system. And, this boy can be, I don't know, like, oh, what is this? This is boring. Urine? Who cares? Your kidneys actually do a lot of other than just kind of like regulate your fluids. They do a lot more than just that. And they're pretty incredible. And you have two kidneys, and you only need one to survive. And really, you only need like a half of one to survive. They have such a high capacity to do their job. So we got like a spare and a half essentially of these. And so let's just get into it. So this is kind of a capillary model of the kidney. And this, of course, doesn't even fully do it justice, but you can just see how densely packed in the vascular system is into the kidney. And they are, I'll hit you with this right away. They are filtering about 180 liters of water slash your blood a day. Okay, and you only urinate about 1 to 2 liters of water a day. So they reabsorb about 99% of the fluid. Okay? That's just one of the functions of your kidney. That's pretty crazy. 180 liters of water a day. Like, go get 180 liter bottles of water or 92-liter bottles of Coke and just like look at that. Like, look at how much fluid that is going through these little organs a day. And like, let's just have a little appreciation for this bad little boy right here. Because if we don't have properly functioning kidneys, you got one of two options. You either get a kidney transplant, which is like, it's an insane list to be able to get on there. Or you go have dialysis a few times a week. And this is the machine right here, a dialysis machine that would have to take the place of, like, just one of our kidneys. You can have this thing in your body do it all for you, or we have this machine right here, that's the size of a small person. And like, this is the kind of like, engineering map, circuit map of like what this thing is actually doing. Pretty complicated stuff. And we're not going to be able to go into all the details of everything that the kidney does. And I certainly don't know everything that the kidney does. But it's a pretty miraculous little organ. It really is. Not only is it beautiful, but it is like just a pure machine of like balance. Like, that's a really kind of good way to think about it. Like, the kidney is an organ of balance. Like, it helps maintain, it maintains your salt levels. Well, first maintains your water levels, salt levels, pH levels. Let's see, what else does it do? It activates it helps your red blood cell levels, And so, yeah, it releases a hormone if you have low oxygen in your blood to make more red blood cells. It stimulates red blood cell production, and that occurs where? In your bone cells. Production. And it activates your vitamin D. It activates your vitamin D. And it does other things as well. But that's just like kind of a crazy little, like, water, salt, and pH of your blood is regulated by your kidney. And we'll talk about all three of those. I won't really probably get into either of these just because we don't have time. But let's just talk about now some of like the regulating these water levels. So this is like our water in a day, and this is water out. And this is per day. So water in. We get a decent amount of it from drinking, actually, obviously. But that's actually not where most people get most of their water. We get about 1,000 milliliters or a liter. I would recommend drinking more than that from drinking. These are averages. These are not milliliters from eating, from food, or water in food. It's about 300 milliliters from metabolism. Okay. Remember that? Remember where that comes from? It's a pretty interesting one. What do you say we go back and see it? How do we get water from our metabolism? Get rid of that down there. What's that? Goodbye. Metabolism water? Wait, you're telling me this stuff connects together? Oh, let's go back to cellular respiration. Oh, when we burn sugar, we get H2O. Very interesting. Where does that come from? Oh, right, we breathe in oxygen, and that absorbs these protons and electrons to make water. Oh, interesting. So we get water from drinking, the water within the food that we're eating, and then also the water that we make when we make energy, when we make ATP. That's where most of our water comes from. So those three sources. We also get, that's actually it. Yeah, that's it. So it's a total of about 2,500 milliliters a day. 2,500 milliliters of water. That's how we get our water. Okay, and then water out. I'll put this in red because this is how we're losing it. Urine is going to be the highest. So we're going to, I just saw like a bug. I thought I did. We're going to lose about 1,500 milliliters a day. And the next up would be through breathing. We lose about 500 milliliters a day. Through our skin, so evaporation through skin, we lose about 300, 350. And last but not least, through our feces, our little poo-poos, about 1,500. So that's about 2,500 milliliters a day. Boom. So you see that? Balanced. So let's say you're not drinking enough water. Maybe you're only drinking 500. Well, then you're going to urinate out less. Your body is going to work to balance this because you're still going to breathe out the same. You're still going to evaporate the same, right? This one too also, like, where's most of this water reabsorbed, right? Because we get most of our water from actually the food that we eat, actually, which is crazy to think about. But, you know, if you're eating cells, it's got a lot of freaking water in there. It's very densely packed. All right. But we only poop out 150 milliliters. So where's that water? How is that water being held? The main function of the colon is to reabsorb water. So right before you have a bowel movement, all that food is traveling through the colon to suck the water out of it so that you can hold on to it. So if you're not drinking enough you'll have like enough water, you'll have very concentrated urine. Um, so if you have like clear urine, that's not great for you. Um, but if you have like a dark yellow, so like, I'll put that like this. So clear urine is maybe you are drinking too much water. Like pale yellow, this is probably, I'll do it like, I don't have all the colors here that I want. Pale yellow is good. And this yellow color of urine comes from broken down hemoglobin. Like you're getting rid of broken down hemoglobin. Remember what hemoglobin is? Let's go back, guys. You gotta remember this stuff. I know you don't. It's okay, I forgive you. Hemoglobin. Let's see, where do I have this? Right here. Hemoglobin. It's the protein that carries oxygen inside of red blood cells. So if this is the red blood cell, it's just a giant sack of hemoglobin. Doesn't have any other organelles in it, no nucleus. It's just a sac. Doesn't even have mitochondria. I didn't even talk about that. But each red blood cell will have 250 million hemoglobin. And when they get old, our body kind of breaks them down, and then we secrete the ones that we don't use. Some of them we use to make bile, and the rest we just get rid of. We don't need them. And it's kind of a yellow color. And that's why your urine is yellow. It's from broken down, excreted hemoglobin. This is also why if you have like liver failure, you get something, your jaundice. You turn yellow in color. I don't know if I talked about that. Makes bile. Yeah, I didn't. But if you have liver failure, you will look yellow from that accumulation, because the liver helps process the hemoglobin. And if the liver can't do its job, then you have all this broken down hemoglobin out in your blood. And so you actually become yellow. So pale yellow urine is good. But if you have like dark yellow urine, you are dehydrated. And if you have like a brown urine, like a dark yellow or brown, you are, or like orange, maybe not quite brown, but like orange, you are really dehydrated. And your body is like really trying to hold on to extra water. And you just don't want to be doing that. So make sure you're getting enough water. That's, that's really important. Like know how to breathe, know how to like eat properly, and know how to like hydrate yourself properly. Like if you come away from this class with those things, I care more about that. Like that you guys use this stuff to be able to like take care of your health and like, take care of your body, rather than like you memorize anything for any test or anything like that. I'm trying to help you guys out here, okay? So be on the lookout for those things. Look in the toilet after you pee. Do it for me. Okay, let's talk about a little basic anatomy here. And then we'll dive deeper into the kind of anatomy of the kidney. All right, so we're going to draw a little human here, just so we can kind of have an idea of like where in the body this stuff is located. See how I do with this human. I kind of feel like I already messed up the shoulders. Yeah, I'm drawing me here. This boy real thin. Oh, cool. Oh boy. Uh, I'm sorry. I gotta redo this. It's not working for me. Okay, that feels better. No, good Lord. That's what I need to do. Okay, that looks okay. That looks more like a human. Okay. There we go. That's not terrible. Okay. So this person's got a nice tattoo on their chest called the urinary system. That's thug life right there, man. That's hard. You got a tattoo on your chest that just says urinary system. That's hard. Okay, so let's draw on our kidneys. And the kidneys are really posterior. They're really kind of deep and they're like right up on your back meat. And you'll see that when we do the rat dissection. And they're kind of like right at your waist. And they do look like little kidney beans, hence why we call them as such. So there's one. And the other. Beautiful. And let's draw in the vasculature. So we'll draw in the vein here. And this boy's real big up here, actually. Nice thick boy. All right. And then we'll draw in our artery. Nice thick boy. Right, because remember there's 180 liters going through this bad mamma jamma a day. It's a lot. Okay, and these guys would have arteries going in and veins coming out. Like so. All right, so these are obviously the kidneys, and they're very posterior. So the kidneys are very posterior. And coming out of the kidneys, we have the ureters. Kind of middle size. Like so. So your ureters go to your bladder. So these are your ureter. And these connect to the bladder. Beautiful. Okay. And then your bladder has two sphincters with kind of smooth muscle around them, around this first one. They have, got muscles lining here. And then the sphincter, I'll kind of demark it by this. And then down here, we also have muscle. And then the sphincter as such. Okay, so this is our external, the one that I'm drawing right now, sphincter. And this is the internal. This will be the internal. Urethral. So this is your part of your urethra now, the tube that comes out of out of the bladder. Internal urethral sphincter. Wonderful science word. And external urethral sphincter. Don't know why this auto-corrected to that. Urethral. Okay, and why do we have two of these? Well, if you get about 250 mils, which actually isn't that much. How many milliliters is this? This is 355 milliliters. So about like how much fluid that's in there. When your bladder has that much fluid in it, 250 mils. So at 250 mils, the internal sphincter opens up. And this is like kind of like, you know, there's a stretch from the bladder. And that signals to open the internal sphincter. So at 250 milliliters, the sphincter opens up as a reflex. So the spine, so the stretch of the bladder sends a neural signal to the spine to then open the internal sphincter. And that's that kind of feeling of like, okay, I gotta pee. Right? And then you're like, all right, I better go pee because I can't sit another 6 hours. You know, holding this, because now I have to hold this. Okay. So now this is going to be stretched. The external sphincter is going to start to be stretched. So this stretching continues. And this will open the external sphincter. Okay. But conscious brain activity can inhibit this. Okay, so we can stop it from opening. All right. Another thing that will prevent this from opening is like anxiety or fear, which is why like some people might have an issue urinating in a public setting, because you need to enter into a relaxed state to be able to urinate, to allow this reflex to kind of naturally occur. But this is what allows us to like hold it. Even though our bladder might be fully full, our brain can be like, okay, don't embarrass me right now. If I get real wet in my pant area, I'm going to be embarrassed. Okay. I think we'll end this one there. Oh, no, let me talk about one more thing. Yeah, there's one thing I want to talk about here. Let's talk about, since we're right here talking about the urethra. Let's talk about urinary tract infections. Urinary tract infections. Okay, so we've drawn essentially a female urethra here, very short urethra. So the urethra would continue on like that. Urinary tract infections. This is an infection in the urethra and bladder. And it's usually E. coli. Same bacteria for the reason why you don't want to eat ground beef. So E. coli is in our digestive system, our lower digestive system normally. And sometimes this is also why you wipe, especially if you're female, from front to back and not back to front. Don't do that. That's insane. Don't go back to front. Usually caused by E. coli. So if you have cloudy urine is usually, so you know, it's like you can't see through it, it's not clear, even though if it's yellow or clear or white, pale, orange, if it's also cloudy, of a UTI, urinary tract infection. That's what this is, UTI. Okay, cloudy urine is usually a sign of a UTI. Women are usually more susceptible. Women are usually more susceptible to UTIs. And why is that? Well, let's talk about urethral length. Urethral length. All right, women. And we got fellas over here. Women got a urethra about that big. Men got a urethra about that big. So it's about 2 inches. 2 inches of urethra. In women, it's about 8 inches. 8 inches in men, or even more. All right, so if I'm a little tiny bacteria and I'm trying to get up into the bladder, I only got to go 2 inches in women. Now I'm infecting the bladder. Whereas in men, it's like, all right, I got to go up here, and then they're constantly peeing to flush me out. It's tough to grow all the way up the 8 inches of urethra. So it usually doesn't happen, okay? The bladder more easily in women because of the shorter urethral length. Not a big deal. You can just take antibiotics usually, and then you're cleared up. Boom, boom. Okay, we'll talk about kidney anatomy and the nephron in the next one. I'll see you there.